vector from vector equation from admit book, question number 5 of exercise 13.5 we are doing right now. The question is written here: O, A, B, C are such that OA given, OB given, OC vector is given here, and they wrote here B lies on the line AC. So if we draw a line AC, suppose this is the line AC, B lies on the lines. We don't know what the position of B. Say this is the position of B. In that case, how we can do that? We need just AB vector or AC vector or BC vector. With any two vector we can prove it. Let us do our working. At AM I'm going to do here. First, if we go for finding the AB vector, let me find out the AB. We know that AB is OB minus OA. OB minus OA. Put our vector OB is 15B written here. 15B minus OA vector is 5A. Now we can find out the AC vector or BC vector. Whatever we want we can do, because relations are same here. Let me find out the AC vector from there. AC is OC minus OA. OC is 24B minus 3A and OA is 5A. I wrote here 5A. So 24 minus 5, which is 24B. Let me write 24B, whatever it is, and 3A minus 5A, which is minus 8A. Now how we can show these two vectors are actually lies in a straight line? Let me divide AB with vector AB. If we divide with any two vector that lies in a straight line, AB divided by AC, or we also can write it, say AB divided by BC, we will get the same relation. Means we're going to write the AB vector 15B minus 5A. See, on the bottom it is 24B minus 8A. From the top vector we can take 5 common, then it would be 3B minus A, and the down the vector it is, if I take 8 common, this is 3B minus A. So now we can cut out these two, only the relation is remaining 5 by 8. After division of these two vector, if we got one constant, so 5 by 8 is a constant here, then we can say AB parallel to AC. This is the condition. AB, line AB parallel to AC. But see, both lines are parallel but having with the same point A, then we can say only ABC makes a straight line. ABC makes a straight line, and we also can say B lies on the line AB. Then you can say B lies on the line, same thing, on the line AC, telling like AB parallel to AC and A is having with the A common point, ABC makes a straight line. Or if I say B lies on the line AC, is the same. Proven system is same here. Proof system is same. So let's go for the question number B now. It's written here, relative to origin, the position vector of P is given and the position vector of Q is given. So it's similar type of question number 4A. This is the B first part. We first needed to find out the vector PQ. By writing PQ, we can write the position vector, which is OQ minus OP. Let me write our vector. OQ is 3I plus 7J. Then OP vector is here minus I, we are writing here plus 4J. Then if we subtract 3I minus I, which gives us 2I, and 7 plus 4, which is 11J, this is our vector PQ. Then for finding the modulus, we have to do square root of this two value, which is 2 square plus 11 square, and we need the exact value. 4 plus 11 square is, I think, 121. So what is our exact value? We may use a calculator to do this. Root over, you can write 4 plus, let me check again, 11 square. It is 5 root 5. Actually inside it gives us root 125. Then our final is 5 root 5. Let you write the exact value. We cannot write in a value in point. This is the answer of this first part of this question, B1. Now second part of this question, unit vector. Unit vector is a common. If we divide vector, main vector, with the vector's modulus, then we will get this unit vector. Our main vector is 2i plus 11j, and its modulus is 5 root 5. We got it in the first question. Then we can write it 2 by 5 root 5 I, then plus 11 by 5 root 5 z. But we are not supposed to write with a keeping the denominator unrationalized. We need to make it rationalize. So just multiply on the both side of I, upper side and lower side. I mean numerator and denominator with the root 5. Then it becomes 2 root 5 divided by 5 into 5 is 25. We can write directly. This is the coefficient of I. Then j coefficient is again 11 root 5. I multiplied with root 5 top and bottom, and the bottom is 25 z. So this is our final answer of this question. That is the unit vector of this question. Now the last question on that stage, question number 3, which is the position vector of AM and the midpoint of PQ. It is written here midpoint of PQ. How to do that? We can do it like by writing like this. Position vector of N means they are asking to find out the OM from here. So we can reach here like OP plus PM, and M is actually midpoint of PQ. If I write that PQ is here, say P is here, Q is here, and M position in their middle. So we can reach to from O to P, then PM. Actually OP vector we already have. OP vector, it is written here, position vector of OP I minus 4j. Let me write it, I minus 4j. Then for PM actually half of PQ. Let me write it, half of PQ. Then it is I minus 4j plus half of PQ. PQ value we already have, which is twice I. From here you can collect it, twice I plus 11j. Let you write, let's write 12i plus 11j. Then it gives us I minus 4j. Then I, if we divide 2 with the 2, then I, next one is 5.5j, positive 5.5j. Now our final answer we would get from here, which is twice I plus I is twice I, minus 4 plus 5.5, which gives us 1.5j. And that is the position vector of M. Position vector of M is twice I plus 1.5j.